All right, welcome back to our flipped chemistry classroom. And today we are talking about problem solving and using molar mass as one of our tools in problem solving. So first thing we're going to do is we're going to talk about a systematic way to solve problems. And so when we talk about a systematic way to solve problems, there are lots of different ways to solve problems. But using a systematic way is going to help us to be consistent and not miss any of the steps that we might need to make sure that we're taking. So first thing we want to do is make sure that we understand the problem. What am I being asked to find? And the second thing is to understand the information that I'm being given. So what information do I have? What do I already know? Then we want to make a plan for how we're going to solve this problem. What equations might I need? What concepts am I going to use? And then I want to check my answer. Does it make sense? Does it pass the common sense rule? And does it have the correct units? So how are we going to use this when we're talking about molar mass? So very often we're going to be asked to find the number of grams of something or the number of moles of something, and we're going to be given the other. So first thing we want to make sure we know is what are we being asked to find and what are the units of the thing we're being asked to find. Then we also want to make sure we know what we're given, what information is given. And in the context that we're talking about now, the concepts that we're going to use are probably going to be dimensional analysis concepts. So they're going to be conversion factors to and from moles. And then we'll check our answers. So just a quick reminder that when we calculate formula mass, we are adding up the masses of the component elements. So if I were calculating the formula mass of carbon dioxide, I'm going to find the molar mass of carbon and the molar mass of oxygen. I'm going to multiply the molar mass of oxygen by 2 because this subscript 2 here tells me that I have 2 oxygens. And I'm going to find that the formula mass of carbon dioxide is 44.01 grams. Now, these squares that I pulled from the periodic table have a lot more information. So depending on what information I was given, I would want to make sure that I matched the significant figures of my calculation to the significant figures on the periodic table. So we want to make sure that the molar mass that we're calculating is not the limiting factor. Okay, so when it comes to what concepts I will need, I want to make sure that I remember we haven't talked about liters yet. But we have these 2 mole relationships. We know that there are 6.022 times 10 to the 23rd things in 1 mole. And we know that the mass that we find on the periodic table is the mass in grams of an element. And so we have a way to convert from grams to moles, and we have a way to convert from moles to atoms or molecules or ions. So this is our map, and we're going to use this as we solve problems. We haven't learned about this one yet, so we'll get to that one when we talk about gases. So first thing we're going to talk about is converting moles to grams. So if I were to ask you how many grams of salt, sodium chloride, are in 3.50 moles of sodium chloride, first thing we have to do is find the molar mass of sodium chloride. So we look up the molar mass of sodium and the molar mass of chlorine, and we add them together to find that the molar mass of sodium chloride is 58.44 grams. Now that's a molar mass, so that's 58.44 grams per mole. So we're going to set up our equation. We're going to start with 3.50 moles of sodium chloride. And then we know that for every 1 mole of sodium chloride, we have 58.44 grams of sodium chloride. We put moles on the bottom so they would cancel out. And we multiply by the grams, and we get 205 grams of sodium chloride. Now notice that this has only 3 significant figures because the 3.50 had only 3 significant figures. So I have a little bit more precision in my molar mass than I need, and that's good. We would not want to use 58 here because then that would limit my precision on my answer. Okay, so that's how I would go from moles to mass. What about if I want to go from moles to grams. So we went from grams, we went from moles to grams. If we wanted to go from grams to moles. So I'm trying to figure out how many moles of sodium chloride are in my container of salt. So I'm going to take the molar mass of sodium chloride that we figured out in the last problem. I'm going to divide the grams of sodium chloride by grams per mole. And I put grams on the bottom so they'll cancel out. And we find that our container of salt holds 12.6 moles of salt. So we've converted from moles to grams, and we've converted from grams to moles. But we have another conversion factor, and that's Avogadro's number. So what if I wanted to know how many atoms of lithium are in 3.5 moles of lithium? So we're going to set up the same way. We're going to start with the thing we know, which is the 3.50 moles of lithium. And we know for every 1 mole of lithium, there are 6.022 times 10 to the 23rd atoms of lithium. We put moles on the bottom so they would cancel out. And we have 2.07 times 10 to the 24th atoms. So we can convert from grams to moles, from moles to grams. We can convert from moles to atoms. Let's look at putting it all together. This would not be atoms, this would be molecules. So we're just going to pause here for just a second, maybe. Okay, that's better. So how many molecules of isopentyl acetate are in 1 times 10 to the negative 6 grams of isopentyl acetate? So we're going to go through our process. What do we need to know? Well, I need to know molecules. What do I know? I know the mass of isopentyl acetate. What's the plan? And does my answer check out? So my plan, I want to get from grams to molecules. Well, I don't have a conversion factor that goes from grams to molecules, but I have a conversion factor that goes from grams to moles, and I have a conversion factor that goes from moles to molecules. So let's see if we can solve this problem together. So we have isopentyl acetate. We're going to switch to the board here. We have 1.00 times 10 to the negative 6 grams of isopentyl acetate. Is that backwards? Okay, so we have 1 times 10 to the negative 6 grams of isopentyl alcohol. So we have C7H14O2. And I want to get from grams to molecules. And so I know that I need to get grams on the bottom here of the C7H14O2. And so we're going to calculate the molar mass. And so that would be 7 times 12.01 plus 14 times 1.01 plus 2 times 16.00. And so the molar mass is going to be 130.19 grams. And that's for 1 mole of our isopentyl acetate C7H14O2. But I'm at moles and I wanted to find molecules. So I'm going to do one more conversion. And I'm going to say that 1 mole of anything contains 6.022 times 10 to the 23rd molecules. And so now our grams have canceled out, our moles have canceled out, and we need to multiply across the top and divide by the bottom. And when we do that, we find that we have 4.63 times 10 to the 15th molecules of C7H14O2. And that's how we solve that problem. So we'll practice with these in class, As always, I look forward to seeing you soon. Let me know if you have any questions.